Hello and welcome back to Friday Minis. Not too long ago on our Wednesday episode, we took a look at C pointers and addresses. We saw how by just prefixing a variable, well, you could change up the variable. You could either have a normal variable and extract the address, the location in RAM in which it is stored, or we can create a pointer variable which holds addresses. Now, in that particular video, all we did was we talked about normal variables. And essentially in such cases, the whole allocating of memory and freeing it up is done for you automatically by C. So that's great, that's convenient. But there are some places in which attempting to do this breaks down. You see, C needs to decide when a variable is valid and when to keep it in memory as a result, right? And C also needs to know when it's a good time to free it. Obviously, you can't just put things in memory and leave it there. Once you're done using it, you should free up the space so that other applications could use that space. The way C does this is it uses a rule called scoping. When a variable is defined within essentially a particular context, such as a variable or a loop, the variable is only valid within that set of curly braces. This is known as scope. And once you leave that scope, the variable gets freed up. While that's fine, you realize that there are some cases in which this could create problems. Let's take a look at this particular example. I have a function here that creates a variable and gives you back the pointer to the variable. That seems to be fine. My main program then calls this function and attempts to read out the value at that particular location. Now, that seems to work okay. And at present moment, we do get the correct value. But what happens after we do some more memory operations? Let's say we created an array like this. Guess what? When we try and look at the value again, you notice that the value changes. The reason why this happens is because the variable only exists within the scope of its original function. When you leave that function, C goes, well, you don't need this anymore, so it gets rid of it, not knowing that you actually still have a pointer referencing that particular address location. Because that space is freed, other functions can now write information there, and as a result, your data is corrupted. Now, this clearly isn't great. If we want to do something like this, we have to be very careful in allocating our own memory. Here's how we do it. In C, we have a function called Malloc, and we will also look at its cousin called calloc later on. Essentially, Malloc stands for memory allocate. How this works is, well, it allocates a certain amount of memory. In fact, you state that amount in bytes. What it gives back to you is a pointer referencing that particular location. Let's try this in our code. Instead of just creating a variable, we use Malloc, and as a result, we set aside some space in memory. Then we write some information in, and as you can see, doing the same set of steps would not cause that value to get obliterated. This doesn't happen because we haven't freed up the memory. We're not relying on C to do that for us. Of course, we do have to free it up ourselves at the end of the day, and that is why at the end we call the free function. This says we are done using that memory and we can now get rid of it. This, ladies and gentlemen, is how you manually manage memory in C. In fact, when you're actually coding in C and you want to play around with addresses, you do have to be quite careful to, well, not have C do it for you and free it for you before you're done with it. And that's why, well, people use Malloc. Of course, there is one tiny drawback with Malloc, and that is you have to know how much space you need. For example, in this case, I only wanted to store a single integer, but I reserved 4 bytes. I did that with the knowledge that integers are 32-bit or 4 bytes on my computer, and so I did it that way. Of course, you can do the math yourself, go 1 times and ask for the size of an integer, you could do that. But the alternative is you could use its cousin called calloc. Calloc does 2 things for you. The first of which is, well, it figures out for you how much space it actually needs to reserve per unit of whatever it is you're trying to store. On top of this, calloc does one more thing. When you reserve that memory, it clears it for you. Here's the deal. When you use Malloc, right, you just say, I want this address and it does it for you. But it doesn't actually change the contents of that particular address. Now, that address was probably in use by someone else earlier on, and indeed, if you tried to print out the value immediately, you would see something random. That is the value stored in there. I don't know who used that, but well, that's what they left behind. Malloc, on the other hand, wipes out that stuff for you. It resets everything to 0, so it's just a little convenience, right? Make things a little bit easier for yourself. So yeah, there you have it. That is C manual memory management by using 3 functions: malloc, calloc, and free. That's all there is for this episode of Friday Minis. I hope you gained some insight today, but until next time, you're watching 0612 TV with NERDfirst.net. Thank you very much for watching. If you like my work and are feeling generous, you can shoot me a one-time donation on PayPal or sign up for a recurring one on Patreon. Of course, you can simply like, comment, and subscribe. You know the deal. For more videos, links to my channel and a related playlist are on screen. Thank you for your support.